To calculate the Bohr radius, we need to use the expression for the radius of the electron orbit in the Bohr model that we discussed in the previous lecture video. This was radius r is equal to epsilon naught h squared n squared over e squared m pi. Now, and I'll make a note here that we also discussed that Bohr you could only define n for 1, 2, 3, and so on. So, just a brief recap of what these constants mean. Epsilon naught is the permittivity of free space, and that is given by 8.854 times 10 to the minus 12, and that's in farads per second. Now, E is the fundamental charge, unit of charge, 1.602 times 10 to the minus 19 coulombs. M is the mass of an electron, so that is 9.109 times 10 to the negative 31 kilograms. N is, of course, these values here. H is Planck's constant. So, with all this in mind, it's pretty easy to see that to find the minimum radius permitted, we just need to substitute in n equals 1. In other words, the Bohr radius, r, we could call that r sub b, is equal to epsilon naught Planck's constant squared over e squared m pi. Because we've just got a 1 on the top, which we don't need to write. And finally, if we sub in all of these values, some of these you should know very well by now, like Planck's constant, and subbing in the other values, we end up with a radius of 52.9 picometers, which is 52.9 times 10 to the minus 12 meters.